Welcome to my channel. I am Keshav Mukherjee. Today I'll explain basic understandings of monolith, SOA and microservice. We can call this microservice architecture as one of the architecture style that we can consider to build our web application. Let's try to take an bank application. This bank application provides products like account, card, and loans to its customer. So for these banks, in order to build a web application, there are multiple architecture pattern available inside the industry. The very first traditional approach that we have to build web application, monolith architecture. Whenever we are following the pattern of monolith, all the business functionality of the bank application, they will be deployed as single unit. If you see here, inside a single server, it has a presentation layer, related logic like HTML code, JavaScript, CSS. Suppose that there is going to be backend business logic along with the data access layer. One of the important feature of monolith it is going to have a single supporting database where we store all the data related to account, card, and loan. The architecture style support simpler development and deployment for smaller teams and applications. If you have a small team or if your application is a very small application, definitely this pattern is going to make sense because it is going to ease your development and deployment. With a single deployment, all your web application is going to be deployed and it is going to be available for the end user. Since we are deploying everything inside a single server, there are going to be a fewer cross-cutting concern like security, auditing, logging. This is going to be simpler inside monolith because all your code deployed inside a single server as an web application. Better performance, all codes is deployed inside a single server. It accounts business logic want to communicate with code or loan. It is just to be method call inside the same server. There is no network call with the help of web service. And advantages of monolithic architecture, it is difficult to adopting new technology. Updating a monolithic application with a new framework, language, or technology require modifying the entire code base as all the components of the application are tightly coupled and depend on each other. So there is limited agility in adopting modern technologies as even minor upgrade takes significant time and effort. High risks during migration. Upgrading a monolithic application poses a significant risk of introducing issues and bugs because the tightly coupled code base means the changes in one part of application can unexpectedly impact other parts. This interconnected nature require extensive regression testing, rigorous planning, and careful execution to ensure stability during upgrades. The process is both time-consuming and resource-intensive, making it a challenging and costly task for organizations to maintain the modernized such system. Lack of fault tolerance. Since all components run in a single process or server, a crash or issue in one module affect the whole application. Full deployment also require monolithic architecture does not support independent deployment of individual module. Even a small change or enhancement in one module require redeploying the entire application. This lead to unnecessary downtime affecting 24/7 application with high user traffic. Single point of failure. All components of a monolithic application depend on a single database. So a failure in the database to downtime for the entire application. Scalability challenges. Monolithic applications are difficult to scale efficiently because scaling the entire system to meet growing user demand lead to higher infrastructure cost and resource inefficiencies as different modules often have varying requirements. The monolith. Typically, there will be a development team handling the account, loan, code, and UI UX inside monolithic application. All these developers, they are going to work as a single code base. Using this single code base, we are going to deploy the entire our web application into a web server or application server with the help of CI/CD tools like Jenkins. In a monolithic approach, developers work with a single code base, which is then packaged as a unified unit, such as an EAR or file, and deployed onto a single web application server. Additionally, the entire application is supported by a single database. So here the major drawback is there is no flexibility to the organization and developer to introduce new features, to introduce new enhancement with that reason, since the companies are growing a lot and since the demand from the end user is increasing on day-to-day basis, slowly the industry migrated to a new architecture pattern, which is SOA. SOA, the service oriented architecture. SOA emerged as an architectural style to overcome the limitation of monolithic application. SOA separate the UI presentation layer and backend logic. The UI logic is deployed on server A. The backend servers such as account, card, and loans are hosted on server 2, managed as independent service. The separation reduces the tight coupling between UI and backend logic seen in monolithic application. SOA introduced a middleware component called ESB. The ESB acts as a moderator that facilitates communication between the UI and backend service. When a UI request is made, the ESB routes it to the appropriate backend service, such as the account service, card service, and loan service. Advantages of SOA. Backend logic, reusability of the service. First one, backend logic is divided into independent services. These services can be reused across multiple application or modules. Better maintainability. Each service is managed and maintained separately, making it easier to update or fix without impacting the other services. High reliability also one disadvantage. Failure in one service does not bring down the entire system since the service operates independently. Parallel development. Teams can work on different services simultaneously. Scalability. Individual services can be scaled independently based on demand. For instance, if account service experience high traffic only, that service needs to be scaled. Disadvantage of SOA: complex communication protocol. Communication between the UI and backend service often uses SOAP. SOAP uses XML format which is verbose and complex, leading to heavier communication overhead compared to lightweight protocol like REST. High middleware cost. ESB typically a commercial product such as Oracle ESB. These are not open source and require significant investment to purchase, configure, and maintain. Additional overhead. ESB add extra layer to the communication process. This increases latency and can complicate the architecture unnecessary for smaller projects. Inside SOA, you can see UI team. They are going to have separate code repo, and all the backend team, they have separate backend repo. Using these two separate code repos are going to have a separate deployment into separate web server. You can see the cat is the communication between the UI server and the backend server is going to happen only with the help of a middleware component, which is enterprise service bus. As I have already explained, it has advantages and disadvantages as well. So next, we have to check why microservice architecture is far better than this. So next class, I will explain the microservice architecture in more detail. And thanks for watching the video. And I'll upload the microservice concept, start everything in the next video. Thanks.